All right, today we're talking about reflections. A reflection or flip is a transformation in which a figure is reflected in a line called the line of reflection. The reflection creates a mirror image of the original figure. You can kind of see a couple of pictures there. The original figure and its image have the same size and shape, but are oriented or facing in a different direction. So here's a couple of little definitions to fill in on your packets. A reflection flips a figure over a line of reflection in order to create a congruent image. Each reflected point of the figure should be the same distance from the line of reflection on the opposite side. That's a pretty important piece of information. So for example, here's an original image, the pre-image. We're going to reflect that across the y-axis. And so the y-axis is the axis that goes up and down. So when we do that, what does it look like? Well, it looks like this. If you notice, each of these points are now on the opposite side of the y-axis, the same distance away from it that they were when they were in the original image. And here are the new coordinates of those 3 points. So how can we represent what took place algebraically? Well, basically what happens is the original x and y values, when you flip it across the y-axis, the x value becomes its opposite and the y value stays the same. So if you notice, 2 became negative 2. This 7 right here became negative 7. This 2 became negative 2. But all the y values that were corresponding to them stayed the same. So that's sort of the important thing about reflections to watch for. Here's another image. This image is down here in the 4th quadrant. Reflect this figure shown across the x-axis. So we're going to flip it across this horizontal or x-axis. When we do that, it looks like this. And the new coordinates look like this. So if you look at them very carefully, you notice that all of the x values stayed the same. But in this case, because it flipped up to the top for the 1st quadrant, all the y values became their opposites. So negative 2 became 2, and these negative 7s both became positive 7s. So if you reflect that or represent that algebraically, it looks like this. X stays the same, y's become their opposite. Okay, now let's take a look at this problem. First of all, it says to reflect this triangle across the y-axis, which is the up and down axis, then describe what happened to each of the coordinates. So when I reflect it across the y-axis, it looks like this. Each of these coordinates moves across the y-axis and is the same distance on the other side than it was to start with initially. So if I notice, the q values just slid straight across, so they didn't change their y value. The only thing that changed was their x value. It became its opposite. So y stayed the same, and x flipped to its opposite coordinate. So that's what happens when you reflect something across the y-axis. What if we flip that same object across the x-axis? So we take this and reflect it down here. So if we reflect it down here like that across the x-axis, what's interesting is that the x values stay the same and the y values flip, because you notice q went from way up there straight down that y line down to q prime and so forth, and so r prime as well as p prime. So that's what happens when you reflect it across the x-axis. X stays the same, all the y values become their opposites. Okay, Bella thinks that this transformation below represents a translation. Is she correct? If so, why or why not? So if you look, you got H and G on the left side. In this case, H and G have been flipped over to the right side. In a translation, you just slide it. You don't rotate it or flip it. So the answer to this question then is no, this is a reflection. It was reflected across a line that lies between the two objects. So now using this chart, compare and contrast translations versus reflections. So there's similar in that the new shape is the same size and the same shape. What's different about these two different situations is that the object itself becomes oriented differently. Like in a translation, it just slides, whereas in a reflection, it gets flipped over and is oriented differently than it was to begin with. Okay, so number 7, use what you've learned to show you where the following points would be after a given reflection. Okay, so if we reflect it over the y-axis, that means the y values are going to be the same. The x values are going to become their opposites. So all these numbers on the right are going to stay the same. All these digits on the left are going to flip to their opposite digit. So let's see what that looks like. So you notice all the y values are still 8. That should be a -1. The y values, okay, the reflection over we've got this incorrect. So all the y values are still the same. You see, notice they're the same as they are in the initial image. And all the x values became their opposites. And then the reflection across the x-axis, in that case, all of the x values stayed the same. Across the x-axis, you notice you went from 6 to -6, 8 to -8. So the y values stays the same, and the x values become their opposite. So that's what's taking place there. So on your answers, or on your assignment, you're going to do what's on the packet. Then you're going to take the answers that you got and put those answers on the Canvas section, and you should be good to go. So just get on the Today button when you're ready to put your answers in and finish this up. And when you're doing your answers on ALEKS, if you did them wrong, it'll let you know if you did them wrong, and you can input them again after you've corrected it. So thank you very much.